So your dumbass friend just broke off the jack you've installed onto his system a mere week and a half, 2 weeks ago, right? And mind you, this was a pretty nice build, pretty nice install, right, I'd say. Right, pretty good quality jack. We have some paper tape here just to really hold the wire in snugly. Then some heat shrink, and then some more transparent heat shrink with the glue, right? This glue kind. Anyway, so the guy completely fucks it up. This is what he was packing before. I mean, some girls do like it this way. I'm not gonna judge, I don't know. But anyway, so he managed to snap this shit the fuck off, right, as can be observed. So yeah, basically there's only one option left, and that is to go full Bluetooth, because I mean the guy's probably gonna yank the Bluetooth connection somehow, but I mean, let's see. So far so good, but he hasn't yet taken possession of it. So I'll swiftly go over the stuff. Lighting is a bit weird here, so let's see what we can do about that. So let's see if this works. So what do we have? I'm actually packing a CSR 8645 here. So these are actually quite old by now. You should not be using them. You should have switched to the CSRA 64215. Those are Bluetooth 4.2. These are Bluetooth 4.1. Not a big difference, but the chips are more modern. They have better equalizers. They connect faster and shit. However, they also do have drawbacks. So they sometimes have issues connecting at power up. These are a bit more robust in that regard. And yeah, it's pretty much where the differences stop. So the way I have this hooked up at the moment, I have this quick charge, this power delivery trigger. So it's going to give us more than 5 volts. Or I think it's set to 9 or some shit. And this is basically, right, we'll have a look at the system and how I've installed this in the actual system later. But I'm expecting to see somewhere between 12 to 20 volts. Like one of those rails, I'm only going to draw like 30 milliamps from it. So I really don't care how strong it is. And so that will be going into this switch mode buck converter over here. So I have a shit ton of these. They're very cheap and they're very good. They're extremely efficient, support high currents. And you can easily draw 2 amps from these, no problem. Right, the output of this goes into the isolated side of these modules, so VCC and ground. Then they go into this Mornson, or they're actually ND or some shit. Anyway, this is an isolating DC-DC converter, right? This piece over here. And this basically galvanically isolates the input power from the rest of the circuit. Otherwise, there's ground loop issues and stuff because of the Bluetooth radio in these. You can obviously avoid that by careful circuit management and stuff like PCB layout. But in such an application where you just have wires dangling, there's no way you can impedance match all the grounds and shit. So anyway, this is a brutal but extremely effective way of doing it. These are highly inefficient, but again, it's not a problem. So basically we have whatever up to 30 volts going into the DC-DC converter, then that gets stepped down to a steady 5. 5 gets galvanically isolated over here, and then gets fed into the board. It also gets fed into this Arduino, which again is a very brute approach.
I ain't interested in making fucking deals. You understand?
I'm not proud of it. I'm not going to say I'm proud of it. But the CSR software suite is so extremely bad.
And then I don't know. I just hate it. I hate it.
So a couple of years ago, I was pretty deep into that shit and I did not figure out how to do this. And now I am not going to relearn the 8645 stack for this one project, right? It's just not going to happen. So what I'm doing is I'm powering the Arduino from the 3.5 volt this board is getting. And these are 5-volt. These are 5-volt boards, but they'll run down to 2 volts, no problem. And if they don't, you can actually underclock them, and then they really should. So I'm running these 2 wires, right? These are actually powering the Bluetooth board, the Arduino board from this Morrison. It's not a Morrison, but anyway, from this isolating converter. And then I have 2 leads coming from LED 0 and LED 1, which are over here. And if you need to do this for the more modern boards, I also have pinouts for those, so that's no problem. Just ask me down in the comments. And what I'm also doing is with digital output 8, I'm actually resetting this board, right? So basically the way this works, we're not going to be able to see it, but I will power it up just so you guys trust me that it doesn't catch fire. Alright, so this goes up to 9 volts and draws very little power, right? And in this case, the Arduino is just printing out the values it's reading on LED 0 and 1. These are set to internal pull-ups. And if it's gonna notice the Bluetooth module is not connected for 1 minute, it's just gonna reset it. And then it's gonna wait for another full minute of it being not connected, and it's gonna reset it again. And what the effect of this is that as soon as you actually come into proximity of this module, it will connect to your phone. So basically, you just enter your house, you're chilled. By the time you take your shoes off, it's connected. You just hit play, or you tell Siri to play the music, and boom, you're playing. No more going into this. Like, it's just horrible. You have to go into the settings, Bluetooth, and then connect to it, right? It's just, there's no way, right? I have no idea why not more people are doing this, but apparently they're not. And sad world we're living in. Also, what I've wrote here for my future self is that the plus 5 volt of the USB is floating. So basically you can achieve this by either snapping off this resistor, which I've tried initially, but there's some pretty thick ass ground planes, and I don't know, 30 seconds passed and I gave up, lost patience. So what I did is actually scratch the rightmost pin, and that is the plus 5 volts. And the reason why I want to do this is I'm not sure how happy this is if you backfeed 5 volts into it, right? Because what comes in here is actually parallel connected to the plus 5 and ground here, right? So I'd basically be shoving plus 5 volts on the battery connector here, with there being a 5 volt supply here that would be powering this Morrison. So this would be getting power from both ways. I don't know, it should be fine, probably won't be, who knows, no one knows. And so I'm just avoiding that. Given that USB is actually a differential signal, you don't actually need power for it. You can actually have a USB wire with the plus and minus completely disconnected, and it will still work. Usually you would need some kind of a load to let the computer know, yo, there's something here, but in some cases it actually works without that. So basically now with this powered up, is it powered up? Like, the lights are so bright here. Yeah, it is powered up. So with this powered up and the ground disconnected, it will gladly speak to the computer, and that's how I've been programming it. Let's actually quickly go over to the computer and then we'll be done. Okay, so over here, it's literally only this one page, so not a lot going on. So what we're doing is, first of all, we're including this streaming.h, and this just makes life a lot easier with printing stuff out. So instead of writing serial.println and some brackets, you could just say serial and have this more common notation, right? This more C++y notation. And it's a lot nicer. So basically I'm just printing some stuff out at the beginning. I'm initializing the pins, right? I've defined them at the top just in case I have a different Arduino board. It's just a lot easier to just swap them in one place. It's, yeah. And I'm using input pull-up, as the CSR boards actually use a low side switch, right? A low side MOSFET to actually turn the LEDs on. So the LEDs are connected via a resistor to the positive rail, and then the CSR chip pulls them down to ground or leaves them floating. So basically, if you have this input pull-up, you'll be connecting a internal 20K resistor to the pins, right, to pins A0 and A1. And basically that'll give you a very high reading if the LEDs are not turned on, because this input pull-up will be the thing that's actually red, or when the chip actually decides to turn the LEDs on, it will overpower this internal pull-up and actually give a pretty low reading. So I've found that it's around 20 to 30, but we'll actually go over the serial monitor and take a look at that in a bit. So I'm just doing 100 millisecond delay. This is just an arbitrary value. You can actually not do this at all. I just want to slow down the rate at which my system is doing stuff. Again, I'm just printing stuff for debug purposes. Usually you'd comment this out, but since this is so not time critical and so not real time of an application, you could just leave it in and have the light blink, and it's a good sanity check to see that your processor hasn't died. Basically, whenever LED 0 is on and LED 1 is off, it means we're not connected, right? Because I've programmed these LEDs in the config tool, and we'll actually go over that in a tiny bit, although given that this is a deprecated chip, you should be using the more modern versions of the software, which I also will probably link below, and if I don't, just ask me. I'll send them over. And basically, once we've hit this this reset interval, which I've normalized to seconds here at the top, right? So 1 minute alone, I'll reset the counter. I'll basically pull the reset line low, which will reset the chip. Wait 100 milliseconds, which again is an arbitrary value, but should be long enough and shouldn't be too long, because otherwise we're wasting time. And then I'm going to pull that line high again. And don't worry, this is not going to pull it high to 5 volts. This high is the highest the chip can supply, which in this case is the CSR chip supply, which is about 3.5 volts. So it's just going to pull it up to 3 point something. And this is just to make the code a bit nicer, although completely unnecessary. Yeah, that's pretty much it. And let's get over Windows. Let's go over on Windows, and you'll actually need Windows 7 32-bit to get these softwares to run, which is a pain in the ass, but anyway. Oh, and before that, let's actually look at the serial monitor, see how that looks, because that's also nice. So I'm gonna power the system up, and let's get the plotter up. Okay, that didn't work. Let's get the plotter up now. Oh, come on. All right. So plotter is working, and boom, that was it. You saw it. So we've initialized it, we printed this out. We're printing the tabletop header, right, over here. \T does the tabs, and this is actually pretty good for printing graphs out. You can actually print more lines in the graphing. So basically, we've started up. It actually starts with both LEDs off, but anyway. So in this case, it started in the not connected state, and we start counting, right? We basically start counting the time alone, the number of hundreds of milliseconds, basically. And at this point, it actually did connect, right? And the other LED turned on, and this LED turned off, which is pretty good, right? You have 2 actual indications of the state, right? So we can have 2 conditions here. So again, like, this just mitigates undefined states that power up, other glitches. I actually removed all the event blinks. So for example, if someone disconnects, it actually has a different blink. I've deactivated that. So we just have this setup when it's not connected, and this setup when it is connected or it is playing. Okay, and you can see it reset the time alone. Okay, so let's go on to Windows and check the CSR software. Alright, so this is what we're looking at. It's a piece of shit Trust 2.1 system. I mean, this is also gonna get glued in place somehow because it should be rattling. And these fuckers are so lucky to have me. Like, I wish I would be my friend too. Okay, so let's see what's under here. By the way, it has this eco mode. I have no idea what that would do, but I doubt it sleeps the thing. I really don't know. Okay, so we just lost power and got it back on. Amazing. Is this the entire amplifier? This is actually not bad. Alright, so this is digital. Very nice. Alright, I actually didn't expect this. But these are pretty modern though, yeah. Alright, so let's take a look at this. So yeah, TPA3110 D2. Do we have one of them or two of them? Okay, we would genuinely need more of these. Otherwise, how the hell are they getting the sub channel? Boy, that is super weird. So is this the sub amplifier or what? I just cannot read this now. I shouldn't actually draw that much power. That's pretty nice. But that's stereo chip, so they must be using something else for the sub. And I am rather careful over here. Right on this side, we'll have the high voltage shit. Right, you can see the opto coupler. So we might have charged capacitors. So yeah, on this side, just the chokes for the left and right channels, and we don't have. Yeah, so this must be the subwoofer amplifier. This chip over here. I don't know exactly what that is, so if this will come on video, ESMT or some stuff. This is the best angle we're gonna get of it. Anyway, so two Class D amplifiers. This is actually quite nice and somewhat unexpected. I somehow expected like old school D class amplifiers, but anyway. So we'll switch views again. And I'll put you guys back on the table. How'd that show up? Kinda bad. I'll try and make it better. And I'll get to work on finding some entry points into this. And gluing stuff in. Okay, so I'll shortly be plugging this in. As a disclaimer, do not do this at home. I'm renting out a place specifically to do dangerous electric stuff in. So just have your home for a simple shit and boom, we're live. And yeah, we have a light on in the back. And so this whole side should be high voltage shit except this cap. What is this? 25 volts. Okay, so we're expecting about 20 volts over here as I've postulated earlier. These TPA3110 chips are very good. They sound super nice. Why don't we have focus? Fuck. Anyway, so yeah, let's see exactly what this is running at and where the positive is. So very nice touch. They've added a small, again, I'm really filming blind here. I have no idea what's on the camera. This is pretty suboptimal, I will say. Okay, so yeah, very nice touch. They do have this tiny ceramic across the main decoupling capacitor, so 15, okay. Yeah, I can flow with that. So what does this eco mode do? Like, that's quite interesting. Let me see. I don't think it affects the main supply rail, but let's see. So it doesn't. Let's actually have a look at the caps for the amplifier. So that should be these. So let's see what they're running the amps at. I would imagine it's 15. Okay. And we turn on eco mode. Still 15 though. So what are they fucking doing with this? So the switch comes out here. And goes over here. So I think it just reduces some bass, but oh my god. Why would you do that? Like, how is that eco? Anyway. So 15, and I think we'll just take our rail from here. If we turn this off, should go down. So let's disconnect this. Let's measure the main decoupling capacitor. See if this has any resistor tied to it. Oh, it does. Nice. Nice. So that is safe to touch almost immediately. Wow. That is kind of nice. So it means the switching stuff actually drains it down to 20 volts. So this might actually work off of here, low voltage supplies. That's interesting. Anyway. So again, just for some style points, you want to be soldering onto something that will not be heat sensitive, such as this common mode choke over here. It's definitely much better to heat this up than an electrolytic capacitor. Especially a, what brand is this? It's actually no name. Oh my god, this actually has no name on it. Why, that is weird. Anyway, I don't think I've come across that before. So this will handle 15 volts, easy, no problem. Do we want the wires to be that long? Yeah, we'll just tie them down somewhere. So negative is green, obviously. I get a very cool feature of the custom firmware here. You have it set to a temperature. In my case, it's 210. And you have a boost button. Hold it down and it boosts up to whatever you set it up to. And in my case, it's 300. So 300, I really go through these big ass joints. No problem. Boom, we're done. So that was easy. Let's, oh, this is still connected, how nice. So negative should be fine, let's see. Whoop. It's alive, okay. Watchdog is also alive, so we're good to go. So all we have to do now is connect the signal wires in and we're done. But there's actually one problem. This will be emitting quite a bit of RF, and it depends on how high impedance these filters over here are. There might actually be a problem, so we do need to test this open and just bring this close by. I've actually had an amplifier where if you'd hold a phone next to it, even Wi-Fi would couple into it. So yeah, sometimes these filter stages are extremely high impedance and everything will couple onto them. I don't know, it should be fine with these TPA3010 chips, but we'll have to see. So for the audio, I'll just be using some shielded cable. So I actually get this 4-core wire. Holy shit. I saying? So I actually get this 4-core wire because in some these was basically 4 cores, but 3-core wire plus shielding, because in some cases I do actually deliver power over it. So right, my main source of income at the moment is modding radios, and some of them actually are complete Faraday cages. Usually, right, it's metal on 5 sides, but the front will have cutouts for the cassette, for the CD, or whatever. In some cases, there's no tape, there's no CD, there's no nothing, and it's literally like a steel box. And so in that case, Bluetooth will not go through. If it has like literally a coin-sized hole, it'll come out of there, no problem. Again, the size of the hole and the wavelength and crap, there should be formulas for that. In practice, like any kind of decent-sized hole is enough. But in some cases, that is not even an option. And so for that, I actually deliver power over, oh my God. So wait a sec. So in those cases, I'm actually delivering power over the yellow wire and sending back the signals over the red and white. Okay, so this is fine. And let's check the entry points over on the amplifier. Alright, so first of all, ground is system ground, so that's nice. So the shielding of the RCA jacks is system ground. So let me see where I can get that from most easily. Okay, so these are ground. Yeah, it's pretty clear, but I will write it down because, yeah, why not? Is this shit plugged in? It is. So G. Left channel. I really need it to be this though, like, where the hell is this? Okay, so both inputs share the ground. Okay, no. So this would be right. And this would be left. A crippling sense of doubt is, I'd say, in these situations quite helpful. Otherwise, you'll just end up doing the entire work 4 or 5 times. It has happened in the past. Of course, not to me, but I've heard stories. There's some hot snot around here. Again, that should not be a problem. This behaves very well next to solder. Even acts as some kind of a flux, or at least the hot snot I've had has proved quite friendly. Again, we have this big ass ground plane over here, which is providing quite a bit of thermal mass. And we're putting in about, oh wait, the reason it doesn't work, and this is an actual issue I'm having recently, this is losing quick charge. And given it's the modded software, this will run on 5 volts, but it's obviously very weak. So right now I'm putting in about 20 watts into this joint, and boom, I have it. Okay, let's get some more solder. Okay. Now we have to finish the end. Okay, so that is technically all of it done. Let's turn it on. Alright, I'll actually have to remove the turn on and turn off beeps. I actually forgot those. But yeah, it should have connected to the phone that's recording, which is a problem. Alright, so we do get music across. Yeah, so interference has been observed to be rather low, so I'm fine with this, especially the volume is set to 100%. That should be fine. So basically next up I'm going to find a way to secure this in place. I'll probably use some M3 screws. This actually does have M3 holes in there. And just affix it to something, and that'll be it. Yeah, basically that's it. If you have any questions, leave them down in the comments. If you need links to software and stuff, I'll gladly provide that. I might forget it initially, but yeah, just bear with me and have a good one.